All right, doing a sound check here. Looks like you guys should be able to hear me. Go jump over here, and yeah, it looks pretty good. I think this is a good day to do a bunch of labs and actually touch some Linux, right? We've been doing all this other stuff. We've been, focusing on getting people into the course and working through the courses and that kind of stuff. We just finished up the security engineering course yesterday. And now we're, in the very last little bit of these Linux administration course for this run. We've got a whole bunch of stuff to keep adding and putting together, but Sundays are for labs. So what we're going to do today, as we often do, is we're just going to go through and put together more of these lab concepts. We have a bunch of these already written up, and I was thinking about it. I was like, well, we could just go through the ones that are already done. Or we could just go hammer out some new ones. So I think that might be kind of fun to do. So these will be up in the Discord. These are all up in our meeting notes section if you want to go through and work on some of these. But yeah, the way I kind of do this is I just set some of these up. And we just start with whatever lab we're going to do. So this will be lab 10 now. We're all the way up to 10. And just kind of go through our different Linux labs that are focused on security, and then we just take notes on kind of whatever we fancy, whatever questions we want to ask ourselves. So the lab for this week is going to be, or the lab for today. Let's do, we've done all the way through 208, which is down here somewhere, but we haven't done some of these earlier things, right? We started up here. If we look at where we started in our labs, we started on like the users doing something, right? You get Linux admin, and then you get attempted user login. We've got our attempted sudo access. So these are all the secure ones that we had done already. And then we did an Ansible package cleanup and some other stuff. Building a CH root jail. So all up in the 200s, but we can still focus on security down in some of the other labs. So let's go do that a little bit. Let's go play with that a little bit. Yeah, 208. So we haven't touched anything 209 or above. For sure, 210 and these kind of things. So yeah, let's do some of those. Let's make sure over here there's no 210. Yep. All right. Well, let's go start with 210 then. That'll be a fun one. So the 210 lab, I'll link to you guys here if anybody wants to do it with me. Is right here. Right here. Oh no, that's 206. That's 206. We need. Maybe I don't know where 210 is. Oh, plus we already did our syslog. Ah, screw it. We'll pick a different one then. All right. Let's start with let's start with NFS then. That's fine. And I don't know why I'm getting that message, because I don't think we have another one of those open. All right. Start with this one. So the lab is here for both of you on both sides of chat. Pull this up a little bit. So what happens is my microphone gets in the way of my right hand when I'm over here using my little rollerball mouse. So it's funny that I'm waiting in queue, because normally you only get stuck in queue if you're doing stuff quite fast. And I'm not really doing anything too fast today, so let's see how this goes. So we're going to do some NFS stuff, and we're going to think about, from like a security standpoint, what would we want to know as we're kind of setting this up, right? Like what are the things that is pertinent to the security engineer in us, right? The Linux admin and the Linux engineer and the security engineer that exists inside of everybody that builds Linux systems. What do we care about here? And it's actually, I'm not used to it taking this long to come back up with a lab. Normally doesn't take this long to come up, especially on my own labs. But let's make sure I don't have any other ones up. Pretty sure I don't. Make sure there's no other Killer Coda labs anywhere. Nah, no other Killer Coda labs out here. These are all different things. There's Ranger downstairs. See all that stuff. Now we'll give it a second to clear. If it doesn't clear up, we can always go do something else. But normally, these shouldn't take too long to clear up. But we're going to be doing NFS today, and we're going to see how NFS behaves for us. Maybe Cloudflare and Google effed up. Maybe. It's possible. I've noticed Killer Coda cracking down a little more on labs, especially on times where labs are kind of busy. So, you know, this just might be their way of keeping people from spinning up too many big clusters. I had started one a few minutes ago, but I would have thought that one would have been cleared out already. So yeah, here we go. It's dropping us in. So if anybody's doing the lab with me, it's on both sides of the chat. And here's what we're going to do. It says your team has determined that they need to use NFS to facilitate file system access across multiple servers for one central location. How might that look? There's a bunch of different ways that this might look in our organization. But we're going to deploy NFS server on node 01, so he's going to behave as our server. We want to know that. And then we're going to share out a file system, and then we're going to verify that the system is being shared out. So these are things that might be important. So here's our little solution. We'll SSH over to node 01. We're going to check to see if NFS is there. NFS is not there. So maybe in this lab we think, why is it important to see if NFS is there on the server before starting the lab? Well, there's a bunch of reasons, but as a security person, so I always tell you guys, step back a second and think about this. You know, we do these things as Linux engineers, and 15, 20 years ago, I would have told you, guess what? You get to just do whatever the hell you want on a Linux box and nobody knows and nobody cares. But that's not the way it is anymore. In the industry, there's so many things tracking. There's security teams and audit teams, and these people that they kind of pester us a lot. They're called our compliant. There are compliance teams. What the heck's the name of that? I'm drawing a blank on the little 3-letter acronym, GRC, right? Governance, Risk, and Compliance. And they're always going to be kind of writing you. We don't exist in a vacuum. I don't just put NFS on a server anymore. So maybe why is it important to see if NFS is already on our server is because we needed to make sure that we all have the same version. We're installing the same version. Also, if I didn't know NFS was on a server when I went to install NFS, I might need to think about my software bill of materials, my understanding of how we build things and who has access to stuff, because it sounds like I don't have a very controlled environment. And I know that it kind of sounds, you know, weird to people outside the industry, but I need you to understand when you're in the industry doing this, control of your systems is very important. Change management of your system is very important. You don't just willy-nilly throw shit all over in an environment and expect that environment to stay clean and working. Think about it like if you got a workbench or a shop or something at home, or you know, you got an office and somebody else came in and messed it up, you wouldn't be super happy with that. Now you can mess it up yourself and that's on you, but like as systems administrators and as security people, we have to think about what's going on in our system. Well, anyways, where I'm going with this is, why is it important to see if NFS is already there? Well, because there's versioning and there's things to consider, and I'm going to have to report this out when we're done, so I need to make sure that we're on the right same versions across the board, right? That could be an answer there to think about. So we're going to install the NFS kernel server, and the next thing that I might want to know is what dependencies were installed on the system, or this first question, and we've been answering them as we go, right? So why is it important? We need to control and report versions. That's very important. You need to be able to control and report versions. And how did we do it? We use dpkg-l grep for NFS, right? So what dependencies were installed on the system? So we might do a couple of things to see how the system, reported this out to us. But the question here is, what dependencies were installed on the system with this? So how do I know what was just installed a few minutes ago on the system? Well, I might be able to cd down into var log apt. And in there, I might have like a history.log. And I might be able to go and look at the history.log. And maybe we just cat it. And right at the end, we see that somebody asked to install kernel, NFS kernel server, and we installed that. Sure. But then we had to put in all this. So we had to put in NFS common, so it was something else. We had to put in key utils. That's something else. We had to put in RPC bind, whatever the heck that is, right? By the way, that's important to know what RPC bind is, right? Lib NFS ID map, so ID map, right? So that's ID map, so you can map users and stuff like that. Okay, so that's pretty good. But what dependencies were installed on the systems? We found that with catting out var log apt history.log, right? Should be that. Yeah. So var log apt history.log, right? And what dependencies were installed on the systems, and why would we want to know this? We need to keep our SBOM, right? It's our software bill of materials up to date for security and maintenance reasons. So you say, what do you mean by like security and maintenance reasons? Well, if I tell you to update a bunch of stuff on the server and you're just going to go run and update all, well, you need to know that those things are going to get updated as well. And if you're not keeping track of that stuff, there's things called breaking changes. What we call breaking changes are where you're changing something in the system, but maybe it's outside of the support of the kernel, or it's outside of, like, there's all kinds of things that can happen to you. So because of that, we really need to understand about what's going on inside of the system, so we need to keep track of it. And the software bill of materials, a lot of times that's something that we give to like a customer or something, but if we are our own internal IT team, we give that to ourselves. Our future selves will thank us because we updated what's on the systems. And your governance, risk, and compliance security team are probably going to be writing you to have you keep that up anyways. Excuse me. Oh, man. So, we come down here. We've got NFS running on this node, and let's make sure that it's running. We see that it's running, and then we see what port it's listening on. So the question here might be, what port is NFS listening on? And how do we find that? We use ss-ntulp, right? And then we see that it is 2049. Why is that important to remember? Or why do we want to know that? Well, we have to document how the system, so we need to, we're going to make this A. We have to document what ports are open on our system. If you work in an environment that's heavily controlled, as far as like, you'll sometimes run into these environments where the maybe you're like in a PCI DSS and there's certain controls that have to happen for your team in that area. They might not be required in other areas of your company, but in that area they are. And typically, when we talk about it, you guys remember doing math where you were trying to add up and you had to find the lowest common denominator because otherwise fractions don't fit together very well, right? This is kind of common thing in like school math and stuff. It's important to understand all your denominators need to be the same. Well, it may be useful to understand that if you're doing something in a PCI environment, a lot of times that's going to seep over. Well, for me anyways, I think it's easier to do this. I'll just apply that security everywhere. Why not? I already spent the time building the procedure that does it, and I've automated it so it works. So why don't I just apply that security everywhere? Now, you say, but they don't require that. I don't care. I don't care if it's not required. If it's secure in one area, it's secure in other areas, and if it's not affecting performance, I'm going to do it, right? Like, that's going to be me. That's my own standard of security, right? You gotta understand, just because we are the Linux engineers or the Linux admin or the platform engineering team or whatever you want to call, I don't even care. You call us mid-range Unix. That's one of my old team names. We didn't even have Unix in the environment anymore, but we were still the mid-range Unix team. We were all Linux, years before that. But where I'm going with that is it's not combative between me and security. I'm securing my own shit. You're just telling me what I have to do to apply things, but I also don't want people in my stuff, right? It's my environment. I'm the one controlling it, right? As engineers, we want to keep our stuff working and under our control. So there's that. Okay. So again, we're doing, maybe not even right now, if anybody's wondering, we're doing a lab. You guys can do the lab. It's up in chat. But we're doing a lab that's not necessarily a security lab, but we're focusing on pulling out like what an admin would want to know about security and how an admin's going to interface with security. We just got done doing a security engineering course with our group, so I'm kind of going over a lot of these things. What exactly is the port? I understand it's a logical construct, but how does it map to hardware? So what the port is, so it's kind of like at an abstract layer. Let's back up for a second. So there's two types of ports that can come in on a TCP IP connected system. Our systems are using TCP IP. That's the type of connection to the network they have. They're actually accessing the hardware using, in this case, probably Ethernet 2 frames. But the TCP ports, the TCP or UDP ports between 0 and 65,535, that's the number of ports there are, and that's 2 to the 16, right? That's how many ports you have that are accessible on your system. They are at layer 4 of the OSI model. They are coming in segments, so above packets. As packets get reassembled into segments, they are looked at, and that source or destination port there determines everything about where they go. So if there's a destination port on there and your system is listening on that port, it will go to the service that's listening to that stream. If there's nothing that's listening to something that gets that high up and manages to get past whatever filters you have, because you should have filters before it ever gets to your TCP layer. But let's say it gets up there and it's readable, then that whatever that construct is going to be read by the application that's listening on that port. So it doesn't really map to hardware. It's something that's in the software that the kernel controls, right? The kernel, as it allows the packets to be reassembled back into data streams, right? Because we're dealing with streams at layer 4. Any stream that has a destination port that one of your services is listening to is going to pull that up and listen to it. Typically with TCP, they're reassembling whatever's there and then passing it up higher for NFS, because NFS exists up at layer 7, right? So, so it's just metadata in a segment that we read. And well, okay, I'll back up all the way. So let's go look at the RFC for TCP real quick. This gets real like in the weeds for people, but suffice it to say, you've got these headers right here. So right, whatever your header is, it'll be right here. It's a stream of bits. Here's a TCP header right here for people that have never seen it. And the source and the destination port, remember I said it's 2 to the 16? There's the source port and the destination port. Now the source port is how our system knows to talk back to whoever the other guy is on the other side. But and that's how the applications talk in the source and the destination. But the destination port, let's say the destination port's 80 on my server, and or in this case 2049. Then I know somebody's attempting to connect and talk over NFS, and then my system my application would be listening to that destination port coming out of this header. So yeah, this is a stream of bits put on the front of application data that's come down to be sent over to the other side. So hopefully that's clear. I wouldn't even think of it as metadata. I would think of it as like the data, right? It's the actual port. And now your system is sitting there. Your system is existing a lot like an island. I always think of it kind of like an island, and it's got all these open ports on it. And only ports that can be connected to can be listened to, because there's no application listening to them otherwise. That being said, even though that is a security truth, like if something's not being listened to, it's not going to be connected to, I still tend to err on having like a host firewall that's also protecting your system, because somebody maybe accidentally puts this on and accidentally opens this up, right? This is now opening. My system's listening on that port, right? SS-NTULP. My system is really listening on these ports, and 2049 happens to be one of the ports that's now being listened to in my system. Where's that? That's why we use the filter. But yeah, there it is. There it is, listening to IPv6 right here, and here it is. Where is it at? This is why we grab. Right, and then here it is listening to all IPv4 addresses, and here it is listening to all IPv6 addresses in my environment. So, yeah, no, Tim, that's fine. I actually don't mind being derailed for the most part, especially when we're just kind of hanging out here. Can I show you, like, in our Discord, because I am, by the way, guys, I'm a professor that teaches networking and also Linux and systems, and I teach everything. But when I show people stuff that's like outside of the college realm, like here and when we're hanging out, I do like showing this book, which is the Red Book. And I think that this is one of the best things to show you. This is dated. This book is old, like, but it's public domain. I mean, when I say public domain, it's still it's still copywritten, but it's publicly available for you guys. So you can go download this book if you want it. But I always show the engineers, because they'll ask me, like, Scott, how much of this networking do I need? And I go, well, my advice to you as a systems engineer, right? Because I started off in networking. I got my CCNA back in 2002, and I've been basically teaching networking for the last 17 years. My advice to my engineers are to read this book up to page 170. Everything up to about 170 is useful for systems engineers to know how your system interacts with the network. There's a bunch of stuff after that that I think is really good for network engineers and people that, like, if you just tell me, hey, Scott, I'm going to eat, sleep, and breathe firewalls and wireless and just the way that our routers discuss things, and like how when I turn on a bunch of devices is the LLDP or CDP, Cisco Discovery Protocol, or what is the one, logical link, the neighbor protocol, right? And you say, hey, Scott, how does that work and how does that talk? And then once I get the devices up and they start talking over the different types of distance vector or link state routes and routing protocols that we have, and how do those update and the timers and all that, and I go, well, that's a lot, but this is at least a good start if you don't know where that is, right? Because there's two basic types of routing that occur. Well, all right. We'll go far afield, but there's two types of routing updates that occur. There are distance vector routing at a high level, and then link state routing. And these are the types of routing protocols or algorithms. And distance vector is always based on hop count. That's the only metric it can use. How far away are you? And if there's one that is 4 hops away and one that is 3 hops away, it will always say the 3 hops are better even if they're slower links. But it doesn't understand links. It only understands hops, right? But link state routing protocols and some of these other ones, path vector routing and these other things, the two general ones you learn about in like a CCNA are distance vector and link state. But link state deals with a bunch of other metrics. It can do cost of the link, which deals with speed and bandwidth and delay and latency and all these other things. And it can build these aggregate numbers that deal with what's the best way to get something. All right, this is an excellent book from IBM. It's dated 2006, so it's a bit old from like there's certain things that are newer than this, but I will tell you from like a understanding the underlying TCP IP that doesn't change, right? That was released in like the mid 70s. This is an excellent way to understand it at a high level for people. So I always use this as a free tool for, you know, our guys down the Discord. Now, I don't really do it much, but if we hop in the Discord, I'll show you guys something. We do have a section down here, and again, I don't get a lot of people talking in it, so I don't really do much. Excuse me, but it's the networking topics, and people will drop networking stuff in here. If you go back, you'll find where I have talked in here around, like I'll link to that book. I've tried to get this going. People didn't really participate, so I didn't really keep doing it. But like I would say, reach pages 67 to 139 of that book. Right, that's the same link. Here's IP, ICMP, ARP, and boot P or DHCP, and then all the RFCs that are kind of relevant, so you can read a little bit about them. And then I say, what's the primary purpose of these protocols? What problem does the protocol solve in the network? Why do we need it? Like, because when you look at the networks, they were originally just one or two machines talking to each other. But as we added more and more, there were more and more problems. So IP does something. IP does a very specific function in networking stack, right? ICMP serves a very specific function to support IP in the network, right? For all kinds of things. ARP does a very specific thing on a LAN. Doesn't go outside of the LAN, it's all within the LAN. What's address resolution protocol doing, right? So this is like a reflection type thing. And again, not many people really participated, so I stopped doing these. But can you find the protocol in a 5 minutes Wireshark scan of your network? So watch Wireshark and do that kind of stuff. So, hey, Monkey Man, how's it going? We are just talking about stuff and doing some Linux and messing around and stuff. So hopefully that's kind of clear for you guys. I can zoom in on this a little bit and make this a little bigger. But this is what we're doing right now. And then I was just kind of talking a little bit about some other stuff as well. Chinglepa, how's it going? We're just kind of messing around and stuff. Yeah, Tim, I would say the first 170 pages are what you want. If you tell me, like, Scott, I want to be a Linux admin or sysadmin, that's what I would focus on. And then there's some stuff that you can jump to near the end. Oh, here's the IETF. Again, everything goes back. The actual engineering implementations go back to the RFC. So I always tell people to read your RFCs. Here's the original release of this one, right? I was just barely born at that point, right? That's 44 years ago coming up. Well, 43 and some change years ago right now. If you're going to read this book, again, a lot of this stuff is for, not outside of our systems range. But then you get down here and maybe DNS, right, would be a good place to spend some time again. And then keep going down and file related. How do we move files around the network? These things start to become interesting again to the sysadmin. But to start, the first 170 pages will get you on a network, right? They've got some good stuff in here, right? And security is a good thing to understanding how cryptography works. Again, some of this is a little dated now because SSL really isn't used anymore. We're all up on TLS 1.3 for the most part, but it's good to kind of, that's a fantastic book for the price of free, right? When people are like, what's a good standard book to like read and understand about? I always give them that Red Book. I think that's like one of the best things. IBM has a bunch of Red Books, by the way. Like this is just one. I think you could probably come back here and find a bunch of their Red Books if I had to guess. Let's go back here. It may be just down here in PDFs. They may have a bunch of them listed even. Oh, here's IBM Red Book. So yeah. Guys, there's like a lot of free stuff from IBM. They've been around a long time. They're big corporate monsters, but they also have a nice little book system. Now, you can't turn around like sell it or whatever, but that's their stuff. But it is something that you can use for free. So I like that. One of my favorite Red Books ever that I used was it's called Tuning TCP IP. I don't think it's one of their free ones. I got it when I was at Lockheed Martin. And the very first thing in the book says, do not do this if you do not know what you're doing, right? Like tuning out TCP on a system, like TCP IP. So you do like sysctl, it's all these commands. Sysctl-a grep 4. Let's do, we'll do IPv4, right? It's tuning all of these things in a system of like a cluster specifically to make it work the best for whatever you're doing. And this is, look at all these things that you can tune. Now they're mostly, so the way I would kind of tell you is out of the box, the tuning for TCP is pretty good. I'd say it's probably going to work like 98% of the time exactly like what you want. We only ever tune this down inside of Linux systems for security reasons or for very edge case performance reasons, right? And you say, Scott, how would I configure these? How would I know what to configure? Well, you would start small, right? So like, this is going to be a flashbang. I'm going to pull my Stig viewer up for a second for you guys. So here's my RHEL 9 Stigs. Remove all filters. There's 452 of them. And let's go for IPv4 real quick. And these are, and maybe we also include sysctl, right? So here's all our sysctl things that we might change. So net IPv4 TCP SYN cookies. Well, what the hell's a SYN cookie? I don't even know what that is. So I go up here, and it says there's a denial of service condition when a resource is not available for legitimate users, meaning if somebody could use a whole bunch of my TCP SYN cookies, then I could potentially run out of resources for real users and real reasons. Within this organization, the organization cannot accomplish its mission, So managing excess capacity ensures that sufficient capacity is available. That is true. And it counters flooding attacks. That's also true. Whatever other things are in place. You say, well, I got firewalls in place for that. Sure. But our individual machines can also be protected. So we need to think about that, right? Employing increased capacity and service redundancy. So what does it say to do? It says to take the value of this, right, and set it to 1. So if it's not 1, we need to set it to 1. So that means that our system is vulnerable in some way if that's set to 0. So let's go over here and let's go look. And it says that it is set to 1. So in our case, we would say that this is set correctly for a security type. What did I say? Security? Yeah. I said securing and security together, and it did not come out right. Okay. So, anyways, back to our system here. We were messing around, and we said, what port is it listening on? We saw here, and why do we think it's important that there are no default shares set up from NFS? So we did a show mount -e, and we saw that there are nothing's being exported from our system, nothing's being shared out. But why is that important to us on the security side of things? Well, it's one of those things where we're not sharing like some default values we have to turn off. We will only share out what we want to, right? That's important. So come down here. We verify the firewall isn't running in this case, but that's just because we don't want to deal with having to turn on that firewall. But we could if we wanted to in the lab. We see it disabled, and then we're going to make a share with the group of no group and the owner of nobody. And then we're going to add this line into Etsy exports. So let's go grab this line. I'm going to hit Shift-G-O, Control-Shift-V to paste that in. And this is going to share out to everybody. There's no limitation of who we're sharing out to. And when I did that and I updated all that, and then I do my show mount -E again, we don't see it in there. And the reason for that is because until we restart the service, it doesn't go back and reread what's in the config file. The Etsy exports is the config file for exports from an NFS server. And if we don't reread or restart the system, it's not going to go reread that exports file. But now it has, and now we're sharing out to everything. And then I would say maybe here, why might we not want to share out our NFS to, right? And this, we always want to control. So when I showed you guys a lot of these setup labs, or when I wrote these labs, there are things that are for the purpose of the lab more like they're undesirable in their security state, right? Like we do not want to leave a system like this in real practice. We want to limit this down. So one of the questions might be, how do we go about limiting the IP ranges that can connect to this server, right? So maybe we need to go read out on the old interweb somewhere. So maybe we come over here to like NFS configurations, right? Something like this. And we go look at like Red Hat docs pop up often, but maybe come in here and we can go look at, okay, we've got the export. We actually do have that if we cat out our Etsy exports, right? Here's our share, our sync, and whatever, right? So this is our value that we have here. And then how might we change that according to this to maybe limit down things? Now we gave some values. We gave it read, write, sync, and no subtree check, But there's a bunch of other values that we could use inside of the NFS server to maybe make this, we could make this read-only. Maybe this is a read-only configuration directory that when servers come up, they go and they connect and they just pull configuration information. They don't actually ever need to write back to it. That's a pretty good way to make sure things aren't changed in your environment. That would be a protection of integrity, right? If we're talking security, confidentiality, integrity, availability. Read-only doesn't protect confidentiality in much way, but it does protect integrity. If it's read-only, you can't change it, right? So it's that. IP Rangers has a ring to it. Yeah. Speaking of Rangers, you guys seen Ranger today? Oh, where is Ranger? He walked away. Normally he's down on his system, but that's my dog Ranger. Normally he'll be down here somewhere. All right. But how do we go about limiting the ranges? So I come over here and I read a little bit and I say export, and we can export to just one host, and that's okay. But maybe we can export to, it looks like by an IP address. That might be a little more locked down. But could I also export to, they say some stuff about that, and then they tell us about the export fs command. That's fine. But do they show us how to do a range? Like a range of like a network? I'm pretty sure they show us here. And if they don't, we should be able to find it somewhere else, right? They give us a little more info about this. Yeah, they don't say it there. So let's go look back here and see if configuring an NFS server by IBM. Let's see if they've got anything good. What do they say to do? Same type of thing. This is probably for their very specific system. Let's go see if they've got a good example of an export file. All right, directory option. We know that. We're familiar with this. You can get real complicated in here. We don't care about any of that. We want to see if we can get... I don't see it. If we want to get it limited down to just... Yeah, there's a whole bunch of configurations in here. It doesn't really matter that much. We've got the system and we can test the working now. But the point is we could limit this down for security reasons if we wanted to, right? And that would be right in here. We would set this to maybe the initial range. Right? And we can go look at, like, how are things going to connect to us and what are we going to trust? Do we trust this network right here? Which is how that system should be talking to us. But just to be sure, let's exit and let's add a bunch of V's to this. See how that communication channel happened. How did we actually get over there when we SSH'd? What port and number did we use to find that machine? It should be right up here at the top. How do we communicate over there? Resolving node 01. So we connected over this. I looked that up because there's some weird connection stuff that actually does happen inside of these labs, but we know that this system, when it looks up node 01 to connect over for port 22, uses this. So that's also the way that we would expect it to try to connect over NFS generically, right? So yeah, Ranger's out networking, that's fair. All right, so we would get out of here and then jump out of there. And we could say, SH back to node 01. Let's go see if we can VI our Etsy exports and say we're only going to allow people from maybe 172 dot, what was it, 16 dot, 172, 32.0. See the /24 there says to map the first 24 bits, which is 172.30.2. 30.2. Right. And let's bang system CTL. So that should restart it, right? And then if we go look at our exports, so show mount-e should show that we're sharing it to that. Now, if that's good, we should be able to move back over here and try to connect to it. So let's see if we can connect on this one. So this was this line. Oops. Let's grab this line. And then our actual thing that we did was 172.30.2. Asterisk, right? And I think there might have needed, no, you know what, we can check. Let's pull this down though. So now we've set up an NFS, now we're gonna connect to it. But we're using a different, we're actually installing something different here. Now we're just doing NFS common for the client. Remember earlier it was NFS common server. So now we're gonna install the NFS common client. And let's just try that mount point and see if that mount point connects for us. We're gonna mount from over there to a location here. So node 01 is gonna resolve as 172.32.2, right? And let's see if we can connect. Ah, so we were denied the mount for that, right? We do a df-h, we don't see it. So let's go check a couple things real quick. I think I messed that up, but let's sh to node 01. We should be able to man NFS, right? And we should be able to go look at this, or let's go forward with share, and we should be able to see sharing information about this. Maybe we even find, yeah, this tells us a little bit about export FS right here, and this may give us some clues, right, about how this system works. So we may have to read a little bit, guys, and I'm mostly worried about if we go to the bottom, Shift G to go to the bottom, sometimes it'll have examples. And there's some stuff how you can use export FS to export things, but we might want to, I think my problem is this. I think I didn't give it. It might be maybe that. Maybe. That looks kind of... All right. Next thing, we're going to back all the way out. And we're just going to do this. Back to the original, right? Because we got to see it work once before we go troubleshooting it, right? Let's... Whoops. What did I forget? Got to do our restart. Mount works fine. So there's something else going on there. I gotta go find that syntax, but that's something I can go look up whenever, right? We're not gonna worry about that now. We're just gonna leave the system like this. So we've mounted it as a test mount, but this is not gonna be a mount point that's really saved on our system. This is not what we call persistent. This is ephemeral. This will go away when the system reboots. We only did it this one time. We did it at the command line with, you know, no consideration for coming back up later, that kind of stuff. So now we're going to do a test. We're going to test to see if we can write in there. Yep, we could write in there. And what happened to our root? Because we're root, right? So this question here, when you wrote to the file system as the root user, why was the file named or owned by and the group? So why was that? What happened? Well, because that's the file ownership on the system over there. And because if we do a mount and grep for MNT, we should see in here that it was mounted. We should see root squash. If we don't see root squash on this side, it's okay. Yeah, I don't see root squash on this side. We just see share there. But if we cat etc exports, we also don't see root squash, but it probably is one of the defaults, right? And so if we do a man on like exports, and then we do root squash. Let's just look for squash. It should tell us all about what root squash is, right? Here's the options that we have, and root squash is right there. So we'll hit N, and then we'll find what root squash does. Map request from 0 to this anonymous UID, GID Note that the does not apply to other UIDs or GIDs that might be equally sensitive, such as bin or group or staff. So what it does is it takes 0. If you come in as the root user, and it maps you over to whatever is the permissions on that directory. And the reason that's a big security thing is we don't want people to be able to write, just because you're root over here doesn't mean you're root over there. Why would it, right? We don't want people to theoretically be able to write as a root user over there and then have root permissions if they can execute something, right? There's old security problems and stuff that came with it. So what it ends up being is you're the sheriff of your little town, but just because you mounted our file system and can use it does not mean you're the sheriff of that little town too. So if you want to think of it like that, that's the way to think of it. You do not have root permissions on that far system. So you get squashed, root gets squashed. And you can turn off root squash. If you trust the systems, you can allow things to be written into your system as the root user, and then the only user on the far side that'll be able to read it will be the root user as well. You know, that could be a thing that you do for, you know, whatever your use case is. But okay, now I'm going to get out of here. I'm going to get out of Node 01, and I'm going to unmount that file system. Right? Where am I at? I'm in root, so it didn't matter when I unmounted it. And the umount-L just verifies, it just makes sure that it's going to unmount in a lazy fashion, even if somebody were in that directory or some process were running in that directory. That's just a useful thing. And it's useful to understand that you can do that, but then now there's other considerations in an enterprise of what you're doing. But for us, we'll call that fine for now. Let's go check on Ranger again real quick. Hold on, I want to see if Ranger made it back to his bed. He is not back on his bed. Guys, it is like 100, what is it in Phoenix right now? It is, well, it's only 92 right now, but it's going to get hotter today. It's going to get in the hundreds. It's only 92 right now. All right, so let's go do something here where we're going to make that persistent now. We're going to VIR at the FS tab, Shift G O, and we're going to grab this line right here. And we're going to hit Control Shift V. And here's kind of the anatomy of this file system, or this file right here. A lot of times your enterprise level Linux is going to have this looking like this, so it's a little more clean and easy to look at, but the spaces are just for us. They're not actually required. But a lot of like Red Hat boxes that you're on, they will look more like this. And it's really, again, just cleaning it up for us. There's Ranger. NFS, and then if you have defaults or any kind of things that you want to consider, and then these will be typically way out over here somewhere, right? But again, these spaces are for us. They're not, the system doesn't care about these spaces. These are more for us to be able to read here, right? Okay. Is it hard to learn to be a network security engineer? Zally Panda, I would say it's going to take some time and discipline, but I don't think it's maybe like hard. I wouldn't tell you that I think it's necessarily hard. It's just one of those things you got to choose to spend time with it. I'm doing right now more like Linux and system security, but if the question is around, let's just say the question is around getting into the networking side of things, these are the things I would tell you to focus on, right? I think I have it over here on the far right, because I just did a review with my college students earlier last week where I would come, this is the CCNA, right? These are the CCNA topics that you need to know, right? Network fundamentals, you need to know network access, you need to know IP connectivity, you need to know IP services, right? And then you need to know security fundamentals, and then you need to know automation and programmability. So those are 6 areas that Cisco says you need to study. And then these are all their sub-things. I took this right off their webpage. This is security, or this is the base networking engineering. And then I was telling my students here as you go through, and the very first topic is 1.1, explain the role and function of networking components. You need to be able to understand what routers are doing, how they're doing it, how we program them, all these types of things. You need to understand layer 2 and layer 3 switches. Layer 3 switches really belong next to router if you ask me, but that's fine. But what is a layer 2 and a layer 3 switch? How do we designate a layer 3 switch from a router, and where the operations occur on the system and the speed of the systems, those kind of things. what is the next generation firewall and intrusion prevention system, and how do we configure those, and what are the, in the Cisco case, they want you to know the Cisco ones, but what are other ones that exist for us to use? What's an access point, and how does that deal with wireless, and how does that interact at layer 2 and layer 1 with the rest of the network, right? How do we program those, and how do we keep those controlled with some type of wireless type controller? What are endpoints, and how do we, know what endpoints are doing, and all this kind of stuff? Servers, and what type of servers are existing on our network. And I'll be honest, as a networking, when I got my CCNA in 2002, I did not know what a server was. I could program the shit out of a router and a switch, but I could not tell you what a server was. Like, what I knew servers existed on the network, but I didn't really know what they were doing, right? And then what is power over Ethernet, and how does that work? And you don't need to know that very deep, but you need to understand that if you need power over Ethernet, you need power over Ethernet devices and media that can handle the connection, right? So that Panda said, for this role, need to be good at coding, and what language is I didn't know any coding when I got my CCNA. No, I guess the coding you would need to know is like the command line. For sure, you would need to know command line Cisco. And the Cisco iOS, which they've been calling it the iOS well before Apple ever called their thing an iOS. The Cisco iOS, I'd say when I probably got my CCNA, I probably knew over 10,000 commands. But when I say that, that's not even that important or impressive. What you need to understand, and this is what I show my students, is how to construct those commands from the base elements, right? They want you to configure a router. There's a set of like 8 steps to set up a router from scratch. You turn it on, you give it its interfaces, you give it a host name, you give it its connection, like how people are going to connect into its VTY, its virtual terminals. You turn on SSH if you want. Like, there's these set of steps you have to do. You turn on any routing protocols, so how it's going to communicate in the network, and then you connect it and make sure that its routing table is doing whatever it's supposed to do, right? Those are like these basic steps. I wouldn't even say bash for that, Zally. No, but I will tell you the one thing that they mentioned in Cisco for the automation piece, they have some stuff that they mentioned down here under their automation. So they want to understand how automation impacts network management. It makes it better because you make less mistakes and it's more repeatable, so it saves you time. Compare traditional networks with controller-based networking. So controller-based networks are doing software-defined network, and you're just telling them what you need, and they're doing all the configuration. Controller-based software-defined architecture. So some of this stuff is probably going to be, I would say Python they're using for a lot of this, last I looked at it. And then they talk about the separation of the control plane and the data plane. That's very important for security reasons. And that comes very much into like STIGs and those kind of things. Then they talk about northbound and southbound APIs, right? And anytime you're talking about an API, you need to know how to query something over a network. You need to be able to look at the codes that come back. Did you get a good code? Did you get an error code? And then when you talk to an API, if you're doing like a GET, you're going to get some block of data back, typically in like a JSON format. And how are you filtering that out and doing whatever decisions on that? So again, I would say like I hit APIs like a lot with a tool called Ansible, and that's Python under the hood. So a lot of the way that looks at the data that comes back to me is through Python-esque, handling. And then they just have other stuff. Yeah, being able to hit a REST API, knowing what create, read, update, delete, what an HTTP verb is, and then the data encoding of like, again, they're going to send you back JSON almost exclusively. So, Zally Panda, you want to know where that node is? Hold on. It's right here. Here is right from the learning network of Cisco. This is exactly where I grabbed this from, right here. So these exact ones right here. In fact, they're pulled right out of here and then just dropped up in my notes. So this is that's the link if you want it right there. And I'll put the link on both sides for people in case you want it. Okay, so how much time do we have left? We have 13 minutes left in this lab, so I gotta get back over to it. But where is it on our thing up here? I think it was. I didn't think it was that far over. admin security. Here we go. Okay. So maybe our next question then was escape colon WQ. We have, so where the mount point is. So here's the mount point. Here's where we're getting the mount, where we are mounting from. So this is mounting from somewhere else in the world, mounting to us. The protocol that we're using, or the file system, is NFS. And then we're taking the defaults, and there's over here, there's these two values here. And these two values right here are, do we ever FSCK this? You will never FSCK something over a network. It doesn't even make sense. And do we ever back it up? So that's what these two values are, right? 0, 0 is perfect for this. So we're going to do that. And then we're going to do a df-h and grep for MNT, or df-h on MNT. Either one of those will work. And the default mount point is set right here. That's where the system is mounted. And now if we've set that all up right and we do a mount-a, right? Now if we do a df-h on mount, we should see that it's mounted correctly off of that node share. So when you used mount-a, what was the message given, and why is it important to understand? So the mount said your FS tab has been modified, but systemd still uses an older version, so you might need to go reload that daemon. And that's important because maybe you're like me and you're an old dinosaur and you've used FS tab for like the last 20 years, but the world's moving on. The world's moving on, and now systemd is controlling everything. So even though I used a mount-a to reread my etc FS tab, the way all modern Linux is kind of going, and this is one of these things I need to go spend more time with, there's a modification where it's actually taking the etc FS tab and it's writing systemd files for mounts nowadays. So it doesn't even really do any of those other things. Yeah, Kelsey, hopefully this stuff's useful to you. You can always hang out and watch stuff later. I always tell you guys, join the Discord if you want. I think that the Discord's the most persistent part of all this. Like, we can hang out and we can talk shop and we can do Linux all day, but I can only be around so much, right? Like, I got to work tomorrow. I've got a bunch of system stuff to do later tonight, hanging with the wife, hanging with Ranger. There's all stuff going on, so I can't always be around, but you guys can hang out down the Discord. By the way, we just hit 4,000 users, man. I think that's wild, by the way. Let me pull up, hold on streaming here. I don't think I have my ticker going. Yeah, let's put my ticker on. There we go. Group professionals, and that's our goal, right? If anybody's here that doesn't know, our goal is to get you guys into doing this stuff professionally. You're like, well, this guy somewhat knows some of the time what he's talking about. And yeah, if you want to do the same type of stuff that we do and get into the industry and do this stuff, that's what we do, right? That's what we focus on. So, all right. So what was that thing? And it said your FS tab. This is just telling us that the FS tab is not the main place to update for system mounts anymore, right? That's it. I mean, that's a truth of it. Is like the world's moved on from like the way that I used to always do it. Now I need to catch up and figure out the systemd mounts better. I mean, I know how to write them and I know where they go, but I don't really mess with them. In fact, it may have even generated them. Let's look here. I don't see it. I don't see it. Sometimes people will put them in here. I wasn't sure if it would generate one of those automatically. Let's do systemd daemon or systemctl daemon reload. Right, and then let's look in here. Nope, still not there. Almost everything doesn't show it either. All right, well that's fine. I guess it's not in there. Now if we go look, it is mounted off of that other system now. So everything worked. It was just a weird message that's newer, right? That kind of stuff. Yeah, yeah. Systemd is the newer way that kind of rolls out. This way still works, but and it's still making the file and it's still doing everything over there. But then if that's all good, we hit check, and then look at us learning Linux. We did NFS. So if we were to draw out, so right, can you draw out what you did in that lab, right? Right. So could you come to here and take a tool like Excalidraw? Now we got a bunch of stuff already in here, but let's say that I was just over here somewhere and I wanted to just make a new little Excalidraw and say NFS, that's like drawing for practice, right? And we were to take this and we were going to say, okay, let's see if we can brainstorm and figure out what we just did. Well, we had 2 servers, so we could probably start with the names of those servers. So control plane, right? And then maybe I also had node 01, right? And this, look guys, by the way, this is more for you, right? Like I would think you would want to draw this out if you were trying to like understand this. And we would say, okay, we installed, so apt apt install NFS server common, right? That was the thing that we did. We put this NFS server common on here, right? Oops. NFS server common, boom. And then that started a little process, right? That was like an NFS server. And that was running on port 2049, right? So we had this port that was there. Now control plane, from control plane, we were able to connect over, right? And maybe we want to make this like a normal connection because it was a normal connection. And then we mounted a share. But when we mounted that share, right? When we did that, over here we had to share out from our Etsy export. So we might need to make this a little bigger and do all this, but we might say share set in Etsy exports, right? So we set share in Etsy exports to be our share, maybe. That's the thing that we want to let everybody know. And then mounted slash share. And when we did that, right, we over here on our system, maybe we think of this like logically again. We go like this and we say /mnt over to /share on that far system, right? Maybe that's how we draw it in our head. Whatever is going to be able to convey for you or your company or for whoever's looking at this later what you did in the lab, right? Let's Control Z that. And then like, could you look at this and figure out what you did from that? And then we talked about, you know, anybody can connect in on this, so how do we secure it? And, you know, whatever. We could then say, okay, NFS drawing for practice. Yeah, I think that was fine. We mounted share from node 01, and the first time we did it, we just did it as a /mnt, just directly on the command line. But maybe, hold on, maybe we also then made it persistent by putting it in the Etsy FS tab. So over here, maybe we put Etsy FS tab entry of this to make sure that this mount share happens or whatever. And again, you might have to draw this bigger and add more and more things, but at the end of the day, you're drawing this out for you. Do I understand what's going on in the system, right? Because that's the goal here, right? Getting this stuff to communicate. Like what did we do? We got this stuff all to talk. We're down to our last 3 minutes, right? It's about to die. But we were able to do everything for the lab to do that. And then not only did we do that as like a Linux admin building that out, we did it in a secure fashion. So we looked at the security components of that as well. So these notes that I have, I think people should take their own notes because I think that's good for them. But two, I will also put these up. I always put these up in the Discord. They tend to go in the like the meeting notes right here. So this is where a lot of times, like I think this was maybe, this was us doing like looking for jobs and stuff. People that wanted to look at that. People have posted different notes for different meetings and groups that they had done. They're doing like a bash study group in the Discord, so people are posting that often. Here's some different things that have been posted for different stuff we were working on. There's just a lot of, I think there's just a lot of good information of people that are doing this stuff professionally out in the industry. All right, so that was lab 10. We'll do lab 11 now. Well, lab 11 in this instance. And what's the next one that we can do? We did NFS. We can set up an Apache web server. That'll be a fun one. This one's pretty straightforward. I will link it to you guys on the Twitch side if you want it, and over on the YouTube side. Hey, Robodom, how's it going? So this is the lab we're going to do, and we're going to ask ourselves some questions, and we're going to do stuff in a secure fashion, right? Whoops. All right, so we're going to do some of this. Actually, and doing this reminds me, I got a customer I got to do some work for a project with my company. So busy time. Lots of stuff busy. And Robodom, yeah, hopefully everything is going well for you. We are, again, not working too hard. We're about an hour in on just working through some labs. We normally do labs on Sundays. I think that's kind of a valuable thing to work through and understand what we're doing and what's going on. Yeah, you can only watch on YouTube, Robodom. Yeah, that's fine. That's fine. No major problems there. We are just kind of working through stuff. Def Not Freddy, do I plan on doing an Ansible lockdown? No. Well, so I do have, by the way, I do have a playbook. It's not actually Ansible lockdown that I have, but hold on. I'm gonna go out of this one real quick to show you. We pull down, actually I don't use lockdown. I use, I forget which one I used. But I think I used the Stig one actually. So shoot. Oh, it's not on any of these. It's in one of the course books. No, but I make them pull down a version of the SCC tool, and then I make them look at. It's like Ansible lockdown. It's just a different way to lock the boxes up with Stigs. But we can look at lockdown sometime if you wanted, right? Like, yeah, right here. I knew it was somewhere in my history. Ansible lockdown. Yeah. I mean, we can go look at what it's doing. It does have all the way up through Rel 10 now. That's kind of cool because Rel 10 has been released, right? Rocky 10's out. Rel 10's out. But we could download these. Now, do I have... Hold on a second. So we can audit and we can also remediate. So we can go over here. And here's our CIS audit, right? And here's all of the things that it's going to do. So I should be able to come up here and say that if I wanted to clone this, right? Yeah. So I should be able to come over here, right? And just, if I jumped in any environment, so I just went in like a sandbox. We'll do a single node environment, that's fine. Just plain Ubuntu box. Nothing special going on. Free environment for you guys, right? And if we just went in here and right, just clone the whole thing down, and then app-y, right? Get Ansible on here. Yeah, I mean, like, we could definitely look at it. Yeah, Def Not Freddy. I touched. Yeah, I did make them do this. Let's go look at where it was. Hold on. So in the security engineering course, that dog, we did in. Let's go look at. Hold on. What week was it? Hardening, securing. It might have been in 1 or 2. I think it might have been in 2. It's all the Stig viewer stuff. Yeah, so I made them pull down but they use the DoD one. So this was a DoD one, which is very similar. I mean, it's just a different way to do it. And then they went and they looked through some of them. No, but I did not directly go into like Ansible lockdown at all. But I mean, at the end of the day, it's you got to set it to configure, then you audit or you remediate, and then you pull whatever info out of it. You know, patch your stuff up, make sure it's good, or in this case, set your STIG values. Let's go look at what it's trying to do real quick. Yeah, Ranger's a pretty good dog. Where? Oh, he's up. He's gone. Who knows where that dog even went? All right. So here's our stuff, and then maybe if we go to README, it says that this is the CIS. This is based on the CIS bench. Oh, I grabbed the CIS benchmark ones. That's fine. Who cares? And it says that there's some variables and some stuff that we can look at, and we can go read all about it. Probably good information in here. But they do have this run audit, which is going to try to do something in my environment. It's going to take a bunch of variables. Let's see what variables it has here. Also, let's move that over so it stops wasting all of our space. We move this over a little bit while we're looking at this because we don't care. And there's all the, change log up at the top, a bunch of stuff, and it tells us some help. So there's some help output. That's good. And then there's the main script, which is going to tell us it's going to read the OS release. It's going to go find whatever information's going on in here. If it's rel or if it's any other one, it's going to go figure that out. And now, did I just grab the one as I did this from? Yeah, it's Ubuntu 24. Okay, good. It's going to go find a bunch of values and a bunch of variable stuff. No, def not Freddy. This one follows a different path. These guys are showing, at least looking at this, these guys have audit. So the way I always do STIGs is like this. If you think of it like steps, I'm going to audit what the system's at, and I'm going to give like the customer a number. The audit out of the box of most systems is like 30 or 40, let's say. And then that's useful because then when we do our remediation and we put it up as high as we can, with still working, by the way, I still have to test to make sure my things work, then the audit will happen again, right? Or sometimes it's iterative, and the audit will happen again, and I'll get whatever score out of it that I can. Now, I don't know what this audit is going to come out as, and that's one of the reasons I'm very reticent to use audits, because if an audit doesn't give me the XCDDF format or whatever the hell they use, I can't import it to my STIG viewer. And you say, why do you care about that STIG viewer tool? It's just a big flashbang, right? Why do you care about this? Because this is the language right here that all the ISSOs in the world talk it. That's your information system security officers. All of those guys everywhere, guys, are going to talk about this. They want it in a checklist, a .ckl file out of here. And this is how we communicate with those guys. You can do whatever else you want and talk about whatever else you want. But if you're not doing that, they don't care. This is the official record. So where I'm going with this is we could take this and we could run this real quick. Let's see if it runs. I'm curious. Ah, damn it. Didn't need two. Just needed one. All right. Pre-checks failed because we don't have this user local bin GOS. I don't even know what GOS is. So is that a tool that they have as a requirement, right? Which is what it maybe sounds like. And maybe if I go finish the README, it would have told me this. What's this GOS.yaml? Ah, so I need to go put this. Where do we get this GOS thing from? So. Okay. All right. Well. Let's pull this down. Let's see. Yeah. Right, so it's gonna pull this down. All right, so that's the most important thing, is it's just gonna put it in there and make it executable. So that's our install process right there. Ah, fuck it, I'm fine with that. And I'd be willing to bet. Yeah, there it is. There's the install. So that's the. So we just chmod 750 install. Right. Just run it. So it'll go grab those things and then it puts it in there, and then. Now it's gonna have. Oh. Oh, they want us to put it over there. We could change that, right? So we've got the. They want this in opt. Oh, fuck them. They can have it. Whatever, they can have it. I'm not gonna argue with them. There it is. All right, so they have a set path. We probably could go find where that is and configure it and do whatever little stuff we wanted. But yeah, let's go see. Let's see what the system as a baseline starts at. So yeah, Def Not Freddy. That's kind of useful. Savage said, "Hey, if I do your Linux course, will prepare me fully for RHCSA, even though it's not on the Red Hat flavor." So I don't think it would prepare you fully. No, I would tell you, if you want to get your RHCSA, you should do the same thing I was just showing with the CCNA. Go find all of the exact things. In fact, there's a few guys doing study groups in the Discord right now. They may even be on right now as we're talking. Hold on. There are study groups where the guys are doing. No, they're not going right now. I don't think. Hold on, let me go look. Nobody down in the chats. Okay, no, because we can see who's in the chats, right? They no, there's a few guys that are studying. I think like 3 or 4 of them that are studying for their RHCSA right now. So no, my stuff won't get you completely there. Although it is funny, some of the guys said there's a lot of overlap, but some of my stuff is on Rocky, and Rocky's going to be pretty close to RHEL. And then some of my stuff is over on Ubuntu just because it's convenient inside of Killer Coda. My focus is always like getting you guys on hands-on Linux. And for somebody with zero Linux, it does not matter. You just need to be in Bash doing stuff. For people that have been doing Linux for a long time, then it is starting. Then I tell people like, okay, Arch Linux is fun, but we've got to do the Linux for the enterprise, which is Bash or Debian or Red Hat or Debian or SLES. Even SLES is a big one in the industry. And when I say Debian, I mean any of its derivatives like Ubuntu. Ubuntu's allowed in government stuff. Yeah. So yeah, my course isn't going to get you ready in that sense. It would generically help get you ready. It would help get you ready for the job, which is again, like, the course is free, so I'm not really selling anything to you guys, but the idea of the course is going to. This was us doing it yesterday. I was going over it with the guys. The course is going to get you ready for these things, these basic components, and then throughout this we have stuff like, you know, troubleshooting and how does the business send us requests and metrics monitoring and all these things. So all these things kind of, we touch stuff like in this week was engineering and system baselining and benchmarking. You might say, why do I need to know that as an administrator? Well, when you first start, you're going to be looking at a lot of stuff, and there's a lot of like, how do we interpret this data? What are the data telling us, and these kind of things. And then we're going to do a little bit with like system hardening and Ansible automation, and we're just going to touch a bunch of tools that I think are useful. But yeah, this course is designed to help people that are doing Linux and maybe messing with it to get ready to be professional, like to put on your little suit and tie and go be a professional in Linux. It's not really suit and tie anymore, but I'm saying like getting ready for that kind of stuff. That's what the course focuses on, not any one certification. And then on the security engineering side of things, we do, you know, hardening a system and how does Linux engineering deal with the security side of things. So the security course is building a system, securing it on the network, allowing users in, setting bastions and abstracting ourselves from the base system, updating the systems and keeping them patched, then a couple of units on monitoring and alerting out of the system, configuration drift and the kind of nightmare that configuration drift is and how we prevent it, and then certificates and keys and how they work in the industry for like identity and also protection of systems, right? So yeah, so the point is those things will get you a lot of info, but they're noise compared to going directly to Red Hat and finding. So I would go Red Hat, RHCSA, objectives, right? This is me. EX200 is that exam. And I would go over here to objectives and I would say, these are the things that I need to know, right? I would grab all these, just like this. I need to know these things, and I would go over here to my notepad. I'll pull this out and I would drop these right here. And then I would sit around and I would work through these things and put check boxes by them and check marks by them as I did them. Do I know what input output redirectors are and what that means? Can I do that? Can I, you know, apply that to a system? And I'll be honest, the guys said that a lot of the stuff that they were testing on was very close to stuff we were doing, but that's not on purpose. I didn't do that on purpose. It's just, this is how you do administration of a system. So, you know, Red Hat understands that well. Essential tools, create simple shell scripts, right? Operate running systems, right? Configure local storage. These, I mean, create and configure files. So these are all the things. Deploy, configure, and maintain systems. Manage basic networking. Again, networking's huge. You're always going to use it. Manage users and groups. This comes directly from them, right? Manage security. And I would not go take any test from any vendor that cost me any money where I didn't have all of these checked. And some of you guys know I have a fair amount of certs, right? I think over on the YouTube side, there's all my certs. Some of those are a bit dated, but yeah, that's my kind of current little repertoire of certs if anybody cares about that stuff. There we go. All right, so over here on backend admin security, if we were doing our lab, we were just messing around this other lab. Here's our output, right? So we should be able to, how many failed? We had a failed count of 327. We had a skip count of 38. We had a test count of 756. So we had a fair amount that looked like they passed then, but we need to focus on the ones that failed probably to try to get our numbers up. So I'm curious to what this audit output looks like. It's in JSON, right? So I should be able to, let's do JQ real quick. We do have JQ. So we'll cat that file through JQ, right? And there we go. And it gives us the output information, but then we should be able to come through and find any one thing if we wanted to, right? If we wanted to look for things that failed and stuff like that, all that kind of stuff. So, yeah, so we could come up here and we could start to dig in and figure out which ones was successful, true, skipped, false. We could start to figure out and find what, you know, passed or did not. Again, this is one of those ones I might not like this because I can't take this, right, as a report. Opt. They just threw it right there, huh? Just threw it out in the open in the middle of nowhere, huh? All right, fair enough. They did put the... They got a timestamp, so it shouldn't affect any other ones that we do. Meaning we could keep running this over and over again and get different output. But the problem is my main problem with this, is that I don't have a way to report this out. Does that make sense? This I could build a little tool maybe that queries out which ones were tested but failed, and then I can go look through that, and maybe they may even have that, right? They probably do. But my point is, if it's not in this, if it's not in this format right here for a checklist, it's I don't want to say it's noise. It's just something I'm gonna have to figure out how to report it out. So a lot of times, you know, you might. In fact, this is my main problem with those other benchmark tools is they don't give me the output I need. But real quick, I may be not giving them a fair shake because they might have that somewhere. They probably do. I mean, these guys know that all of this stuff is predicated on reporting it out. And ISSOs literally only care about getting checklist files. They do not care about anything else. Let's go back to where we were in here. Maybe they have, when they create it, vars.machine ID, maybe they have an option. And they have useful info in here. They have all kinds of good stuff. But yeah, I don't see an option for that. So I might maybe go look back in here, right, in Ansible Lockdown, and I might search their docs for right, checklist, or more importantly, CKL, which is the extension of that file. So if they're not, because here's the thing, again, if you're not reporting that out, it's wonderful. You can do it for your own team and make sure you're updating stuff. You're not going to be reporting this out to anybody, you know. Security is odds with usability. That's a fair statement. We often say security is the enemy of productivity. That's the old statement. Is this your system and compliance through Ansible? Sure. And Stigs are the one that we mostly use, or the ones that I use. Yeah, this is good. They do pre-remediation, so they do very similar to me. Pre-remediation, audit, get the output. Do your remediation, change things to bring them into compliance. Post-remediation, make sure things are good, and then summary and show, you know, what's done, and typically send that out in a way that can report to our ISO. Oh, it's our ISSO, but interesting. Yeah, I think they have, I mean, they have interesting stuff, interesting methodologies in there, but yeah, that's kind of like, you know, me playing with it and running it. And then we can try to remediate the system too. There's that. All right. Anyways, where were we at? We were going to do this next lab. So copy this link, and we're going to put this lab in here, and I'll link the lab to people that want to do it with me. But we're not going to do it just yet. We're going to go take a little break. And I don't know if you guys saw this, but when I go on breaks, check this out. I can go on break here, and I can actually just pull up. Hold on a second here, real quick. Watch this. I go on break, but you guys still have to listen to me. Hold on. Let me make sure I have. This is the next one. We already did the other ones, but this will be Unit 4. Okay. And it's funny that it's near the end of Unit 4 because it needs to be near the beginning of Unit 4. Anyways, I'm going to pull this up for a little bit, and I'll go walk away for a few. And actually, you guys will only hear me until I turn off my mic, but you guys should be able to hear the video. All right, let's get ready to get going here. Check my live. All right, let's go check out our. That doesn't really matter. All right, so let's go ahead and start this up. We'll go to here. My name is Scott Champagne, and this is the Linux Systems Administration Unit 4 presented by the Professional Linux Users Group. We're just going to go ahead and get the recording out of the way. We did our class yesterday, but this is for everybody else who missed it. I should be on Twitch and YouTube, so this will be good for people for recording. I will add this to the playlist, and we'll kind of go from there. Hey, Austin, how's it going? All right, so we're going to get right into this, all right? So, Linux Systems Administration Unit 4. So, here's our announcements. If you have any questions, ask them in Discord. And when I say ask them in Discord, I mean there's a thread to go ask me questions about the course. I don't necessarily mean to like direct, because what'll happen is I'll just get inundated with a lot of direct questions. We got a lot of people doing the course. We're up to almost 200 people, and then just people in general messaging me. So I do ask, if you've got a question, somebody else has probably had that same question. So if you would do me a favor and try to message in the appropriate channels for that. If I had any announcements or reschedules, they'd go here, but I do want to remind you, just hold all your exercise sheets. There's actually like a worksheet for each week. Just hold on to that. When I was trying to grade them with less than 40 people, it was a little easier, but now that we're up to like, again, almost 200 people, I'm just going to say, just send them all to me at the end. So you guys will figure that out when we get there. So, all right, we'll get into that. This is Unit 4, so people that have been following along already have the first 3 weeks done. People that don't, I guess you get to go start now. I guess you get to go back and look for it, but I'm going to show you where everything is. So actually, let's go do that real quick. In our Discord, which you're welcome to join, Discord's free, right? The courses, yeah, we got 191 people saying they're coming. We had 50 plus people yesterday in the week 4 meeting, and then we had a guest speaker come in as well. Where you would go is you would drop into your Prolog projects section, and then here is all the material for the course so far, all the weeks back. We're just going to be doing everything out of Prolog projects. When you start interacting with the discussion posts, you'll see them popping up here on the left side. So if you're not used to Discord, Discord doesn't show you a lot of stuff until you start interacting with it. And then once you start commenting in the discussions, you will find your answers there. Now, there's 2 posts each week that you have to do. You have to respond to the question, and then you have to respond to somebody else. So like that's not necessarily a rule for past stuff. You at least have to respond to the past stuff. But if you were doing Unit 4 right now, you would be doing your post, and then you would be doing a response to somebody else. And I'm going to get into what that is here in a second. There's also, for people that are way behind, there's a playlist back here for the Linux Systems Administration course. And if you click on this, it'll have Unit 1, 2, and 3, and then now we're recording 4. So that's where we're at, all right? That's how the Discord kind of works. I can't help you out completely with that. You got to go figure that out, but Discord's a pretty simple app, I think, to figure out. So what did we talk about last week, right? Last week for Unit 3, we did a lot with disks. You guys got in the lab portion. You carved up physical raw disks that were attached to a machine, block devices, right? And you added them into PVS or LVM, Logical Volume Management. And then you did your PVS, VGS, LVS, and then you said, okay, there's nothing there. And then you carved up those disks. You aggregated them up into volume groups. You carved them down into logical volumes, and you did all this work. Then you tore it all down, and you did an MD-ADM software RAID, right? So that was kind of stuff we did last week. And last week, we were really focusing on triaging an incident. Now, I didn't tell you that we were triaging an incident. I just said, go look up what triage is, and then you did a bunch of research and that kind of stuff. And then I also had you go ask Google or find a blog or ask an AI about high availability and give me some of the terms that you learned. That was last week's work. We also had a worksheet and a lab that you'll have to go pull out of the Discord if you want those. This week, however, we are continuing that theme, and we're going into running operating systems. So we've got a system running, and we're going to go into that system, and we are going to make sure that it stays operational, right? We're going to check it out, maybe like we got a call in the middle of the night, and we were going to figure stuff out. So our topic 1 discussion, again, you would be doing a discussion post and then a response to somebody, is you're going to read this article, which has to do with operations bridges. And then I want you to answer some questions in the discussion that have to do with what do you think is a barrier to entry on starting up an operations bridge for an organization. And an acceptable answer is there's some cost involved, right? You got to have manpower. You've got to have a 24-hour operation. You have to, like you probably have to be a certain size company. But there's a bunch of principles out of operations bridges that you can run even if you're just some engineer getting alerted by PagerDuty or OpsWorks or something. There's still a bunch of work for you to go do and get good at. All right, and then topic 2, your team has no documentation around how to check out a server during an incident. So you're like, I don't know what to do. And write out a procedure of what you think an operations person should be doing. So let's go look at these things in the actual worksheet here in a second. So we'll go, and then we've got a final project for the whole 16-week course for people that want to get the little certificate. You're going to have to do a final project, and I'll show you right now what the final project looks like. You want to start gathering materials for this, and then there's the worksheets and the labs, right? So let's go look at the worksheets and the labs. Let me start with, I don't have the project open. Hold on a second. Let me get this out of the way real quick. Project. There's the project. Close this down. Let me move this up a little bit. All this stuff, by the way, because I already know the question that's about to get asked. All this stuff is in the Discord. It's all right here in the Discord in the Prolog project section. So all this stuff I'm about to show you is right here. So you don't even have to ask. There it is. All right. I tell you guys all the time, if you want to join our Discord, grab all the stuff, throw it in your sack, and run away like a cartoon villain. I don't care, right? Like, just do it. Dipkis, wasn't the Saturday session roughly 2 hours? I mean, I guess. Yeah, I mean, it was over. It was about 2.5 hours if you take the time in from the other person who was talking. But we don't have him to record today. We're just recording my part of the session, the work part of the session. The guest speaker was kind of like a guest speaker in college. You kind of have to be there for him, right? So, yeah, his part's not recorded unless somebody recorded it for him. So let's talk about the worksheet. Here's the worksheet for the course. You come in here, your instructions are to fill out the sheet as you progress. I would advise taking notes. In fact, I was telling the guys yesterday, if you're doing this course and you're hanging out in the little session, I would have at least a notepad of some type open so you could write stuff down and take stuff that's interesting to you. And I would have at least a terminal open so that you could go do work in the system, right? So these two things are kind of a must for doing anything in this class. Make sure, if you want to learn something rather, and you want to actually get better, you should have a terminal open because we're going to do some terminal work. And, we don't have to quibble over what the term terminal means, but something with bash. and then a notepad, right? We had that happen a couple weeks ago with the terminal thing. All right, so anyways, because people want to focus on the thing that's not important, not the thing that is important, and it's tremendously embarrassing when that kind of stuff happens. But anyways, all right. So Unit 4, discussion post 1. Read that article that I showed, and then here's the questions. And you got to answer these questions at a level that you find acceptable. You know what? If you go through that, if you read that and you go, none, yeah, no. Okay, well, I mean, you learned as much as you wanted to learn. I'm not charging you guys anything for the course. The only thing you're going to get out of it is if you want to. I mean, it's the same thing like if you go with 3 of your buddies to the gym, and when it's your turn to get up and rep the weights, you just go, well, I mean, okay, you got what you wanted to out of it. This is for you guys, right? And I'm not trying to shame people here, but you're only going to learn as much as you want to learn with anything, right? Whether you're using this course or something else. So do whatever you guys want. Anyways, Unit 4, discussion post 2. Your team has no documentation around how to check out a server during an incident. And now that might not be a big deal to you because maybe you've been working with servers a long time. You're like, that's good. But I'll tell you what, if there's an incident and one of your junior engineers is on the call and they don't know how to check out a server, guess what happens? They escalate it to you, and you get called out on your you get called out as a secondary on your call out week. So it's a hassle, right? So you want to, I tell people all the time, you want to warranty your work and your documentation at a level that you get to have a nice weekend without being called. So this is a thing, right? So anyways, our discussion post is, these are the two posts. Read an article, answer some questions, and then read another article, and now you've got to go write out what you would be doing to check out a server during an incident. So I said right here, full disclosure, you may use an AI for this, but let us know if you do. So if you use an AI and say, how would you check out a server, and you let it go gather all this stuff, I'm okay with that. Look, these are real tools that are going to be available for you in the industry. I'm just saying, let us know if you do that, right? Most of us will know anyways, because kind of how the level of writing changes for people. Then we've got a bunch of definitions and terminology that we're going to talk about, and I say, hey, take notes as we go, so you could take notes in here. If people are dropping links in the chat, and if they're using terms and they're talking about tools, like everybody's always talking about Obsidian, but if you're not taking good notes and you want a good note-taking tool, Obsidian's perfectly acceptable. So you maybe put down Obsidian, right? I need to learn how to use Obsidian or whatever. All right. So then the week for this week's work is, we've got a lab on operating running systems. I'll show you guys the lab. We don't do the lab during the live sessions though, and that's something I want the lab to be something you guys can go do. All the hands-on stuff I have you guys do later, except for the stuff that we kind of do while we're just working through and talking through stuff. So begin working on your project from the project guide. So we've got a project guide. I'm going to show you guys what the final project for this course is going to look like. But here's your general idea of topics around Linux systems. So everything on there has Linux at the beginning of it, right? Linux system stability, Linux system performance, all that. And then I have a little bit about like digging deeper. And I talk about like from a kind of high level, maybe even what most people call like a philosophical level. What's the term battle drill? What's a battle drill? And why would it be important to understand that you should understand what's going to happen and you should know how to use your tools before an incident happens? You don't want to be like, look, you guys don't want to go to Wireshark and try to be figuring out Wireshark. Look at this big old complex. I don't know if you guys have used Wireshark, but if you're using Wireshark for the first time, it can be an extremely complex tool to understand. And would you want to be called out at 2 a.m. and working on a server and looking at this for the first time? I would argue no. I would argue I would want to understand some of the stuff that's in here and the tool. I'm not talking about the concepts. You already have to know the protocols and that kind of stuff. You're not going to learn those on the fly. But I would argue you want to know how to use your tool to look at things and to, like, let's say I go to this TCP and then I know that I can follow the entirety of this TCP stream to see how the communication occurred on the system. But I wouldn't have known that. I can't figure that out in the middle of the night when I'm like wiping sleep out of my eyes and trying to get servers back up. So my point is, like, battle drills are this concept of doing things so that they're reactionary even if everything's going wrong. You know where your documentation is. Do you even know where your company keeps all its documentation? Like, this is kind of an important thing, right? All right, so then we come down here, reflection questions. What questions do you still have about this week? And then this is one, we've been talking heavily about like taking notes and practicing, and some of you guys have been giving each other good, I would think really good advice in the discussion around how they take notes. And I've seen, look, some of you guys take really good notes. I've seen some of your notes stuff that people have been sending. One of the guys is taking a blog, he's been writing a blog about the course since the beginning. And like, his stuff is so good that I'm probably going to ask him at the end, hey man, can I like take that from you? Because like his notes are so good over all this stuff that they should become the standard for the course. They really are that good. Like the answers and stuff that he has and the way he goes about it. And now, is he any smarter than any of you? Probably not. Like, I don't think I'm any smarter than most people. I've worked with some tremendously smart engineers over the years. The goal is to get good at what you're good at. And then to like new people or people that are outside of it, you're going to look like you're really smart anyways because you understand your tools, right? You understand how to build the thing and how to fix the thing and that kind of stuff. So anyways, all right, that's we're not going to save that. That's our worksheet. So let's go look at the project real quick. Here's the project for this week. And we went over this last night, but now we're doing the recording. So people that manage to make both, maybe you're seeing some of the same stuff. But here's the Prolog final project. So this is, if you're doing the whole course, and you have done all the worksheets, and you've done all the discussions, right, which you can go back through and do the discussions. The last thing you have to do for this is this big final project. And this is going to be your project that shows, you could pick anything that's interesting to you in the Linux world. I literally do not care what you pick. The goal for you is to learn something and to deploy something and then have something to show a company like, I know how to do this thing. I have a bunch of things that you could use as like archetypes for this and a bunch of labs and all kinds of stuff like that. But my goal here is to get you guys building something that shows that you understand these systems, right? So here's your instructions. Here's what you're doing. You're selecting something you want to research or work on and build. Then you're going to plan the project out. You're either going to find documentation of somebody doing something similar, like, oh, I want to build a 3-tier app in Kubernetes, and I want to just deploy some Go that goes ahead and talks back to, maybe a Go container that's going to go ahead and talk back to some MySQL instance or something. Or maybe you're like, I hate MySQL, Postgres. I don't care. I don't care what you use. Plan the project out, find documentation, do some research, get yourself some working models to go from, and then document what it takes to build this project out, right? That's your first pass. Then do a diagram of the thing you want to draw. This can be on Excalidraw or draw.io. There's a bunch of free stuff out there. You do not have to spend your time buying Visio or one of those things. Visio's expensive. I think it's like a $400 a year license, right? You don't have to go do any of that stuff. There's free tools out there that are really good. I don't show you guys draw.io on stream very often, but that is as close to as close to Visio as I can think without actually paying for Visio. That's draw.io is excellent, and you can export your stuff. You can actually take draw.io diagrams, and I'm pretty sure you can put them into right into GitHub, and then they come out like so people can click and go right to them. Pretty sure they do. Excalidraw is also open source, so if you don't trust drawing on excalidraw.com, you can run your own instance locally. So there's all that. Then I want you to build it. Get screenshots of it built, make a video, basically prove that you built it in some way, right? Then I want you to go through and finalize your documentation of how you built it and do what's called redlining the documentation. Redlining is the idea that you take this whole thing, so you build some server. As an engineer, you build a server a certain way. You apply whatever system stuff and whatever you want to do to it, right? And you get a server a certain way. And then what redlining might be is we just tear it all down. We just go back to a bare metal server and we build it back from our documentation. And if at any point in that documentation something is not going to work because when you get there you assumed that they had the ISO mounted because when you were fiddling around with it the first time the ISO was already mounted like in a IDRAC setting or something. If it's not there, when you go to do it, you redline, you put a red line through your document. This is how we used to do it at Lockheed. We would have physical documents and the test team, the QA team would sit there and they would go line by line through your documentation. And if something didn't work, they would literally put a red line through it and you would have to fix it. And then you would have to be ready again when they come to do it again. And everything had to work with no questions, no, oh, let me just fix it real quick. None of that stuff could happen in a red line because a lot of times we have to give this to somebody else to build later. In fact, that's something that I say is you should build something to a level that some other person with no knowledge of it can build through. And that's really what you want to get your documentation to as a level. Then I say prepare to present. You don't have to use PowerPoint like I do. Look, people come on here all the time and go, why are you using Windows? Doesn't matter how we get into Linux, right? But there's a tool called Overleaf, which is an excellent open source tool. This is, by the way, open source as well. You don't have to use overleaf.com. You can go download the Overleaf. There's a GitHub for it. You can run it locally in Kubernetes, and you can go build your own little super nice presentations out of there. I have friends that are working on their doctorates that use this for their presentations. It is super clean presentation. Do you guys want to see here? I'll pull it up real quick if some of you guys haven't seen Overleaf. Super, super clean presentations for free, right? And it's markdown. So on the left it's markdown, but over here on the right it looks like this. So let's come down here and let's just go to like journal article. You were going to write a journal article and you wanted to do a bunch of math or a bunch of diagramming, right? Here's an example. You can download it as the source, so you can import it and change all the language, or you can do it as a PDF. The ones that I really like, by the way, I thought about doing this whole course in this because the presentations are so nice. Let me show you this presentation thing that I think is really cool. Let's say you were doing, here's College of Presentation Themes or something, right? And then I view this as a PDF here. Right, so hold on, let's get the PDF. The PDF might look, oh, it doesn't look too bad, okay. When you get into the presentation, these guys don't do it. But this is what it looks like as a PDF. Not bad, not bad, but hold on, I want to show you guys this. Let me see if I can get one of these other ones, hold on. Because sometimes there's these other themes that you can use. Let me see if this guy has it. Sometimes, he doesn't have it. There's one where it shows you across the top where you're at in the presentation, and I really like that one. Well, let me see if I can find it here. Let's see if this one has it. This one's not doing it either. All right, well, I don't have a good example of it, but the point is Overleaf is free, and you can do all kinds of stuff there. All right. Let's just keep going here. Try to find one of these. Beamer template. Let's see if this one has anything good. I just want to see if it'll give me... look, they have good stuff that shows... I mean, look, that's an excellent example of things you can do. But the one that I really wanted to show you is across the top. It shows you in little bubbles exactly where you're at in the talk. So I have examples of it up on the Discord for people that want that. But the point is, do you want to present, by the way? So are you thinking that this is good enough to present? You can go ahead and present in the last couple weeks of our class if you want. I'll pull you guys up on stage and you guys can present your topic. But nobody has to, right? I even say down here, presenting to us is voluntary, but definitely possible. If you want to get some exposure time before you are going to take this with you to as part of like a portfolio as you go and look for work in the Linux systems administration world, I'd definitely let you guys come and practice in front of a group if you need it. All right, so let me pull myself back up here real quick. I'm going to go back to streaming. Pull myself back up here. That was just me taking a little bit of a break. Yeah, you guys can hear the desktop audio again too. Okay, so that was like part of the course. I'm just going to pull those up in the future when I go take breaks or walk around or whatever. That's what I'm going to do. So anybody that came in late is like, what the hell? He just switched context. Yeah, we weren't really doing that. That was just something I was playing in the background so you guys could hang out. What we've been doing today is we're actually, let me unpin those real quick. We are working on, unpin this message and unpin the message. Okay, so what we were actually doing today was security engineering, but we were asking ourselves questions as we did these different things in the lab. So we already did the one, and we did, for NFS, we asked ourselves what might an admin that's doing security in the system want to know. So we asked ourselves security related questions around that, right? And now this next one, we were going to do some Apache. So let me copy this link. I actually dropped the link right here. If anybody wants to do the lab with me, it is right here. So you guys are welcome to do this with me. Excuse me. So your team has determined they need a website to test deployments rapidly. You have been tasked with installing a web server on node 01, deploy an Apache 2 web server on node 01. Okay, you can do that. Capture the version and install Apache 2 for your records. So, okay, good. And then verify that node 01 is listening on port 80. Okay, do all those things. So SSH over there. We'll verify that it's not running and we don't see that anywhere in the system D, right, for the system running. So we're going to install Apache 2. And then we might ask a similar question from earlier. Why is it important to verify that the package is not in your system? Well, from a security standpoint, you're modifying a baseline. You're modifying the way that system's set up. And if that's something that you need to track in your system, that's a thing to know. Like, we're modifying how the system behaves, so we need to keep track of that. So whatever we just installed is going to be right here. So we installed Apache 2.4.58. Right, so 2.4 is the general version, which, by the way, there is a STIG version for this. So there is a STIG for people that are keeping track of security technical implementation guides. We can STIG Apache 2.4. Here's the general things. I gotta sneeze. Oh, man. Sorry, guys. That was a loud one, I know. I gotta check here. Now there's 47 things that we can do to harden this. So if we're adding Apache to our system that just had no Apache on it, and if we have certain security requirements in our organization, maybe we have to have STIG compliance for things that talk to government systems or something, then we need to ensure that we are adhering to oh man, excuse me. Oh, sorry guys. I don't think I've ever blown my nose on stream before, but oh man, sorry. So we're making a security change. Oh, this is making me cry. Jeez. Oh, somebody's gonna catch a clip of that or something. But anyways, okay. Q, is the security course currently running? No, it's done. It finished yesterday. Are there regular sessions in the DSC for the security admin course, or is that the security course? No, so the security course is security engineering. I'll always make that distinction. This is just me doing security admin stuff. We're just talking as like an admin and looking at systems and stuff. So, but to the 2 points of your question, Monkey Man, is one, no, the security engineering course is just 10 weeks. It just finished yesterday officially. We only had a few people finish it. If people want to start that again, I will probably start the official one again. I don't know. Like, I have a hard time. You guys got to understand, I have a hard time committing that much time because we always have like, that course had like 150 people say they were coming, but we only have like 3 people end it because there's a lot of work to it, right? And, you know, I'm not going to tell you people are allergic to hard work, but people are kind of allergic to hard work, it seems. Anyway, so where I'm going with that is, like, and I don't have any easier way to show people this. Like, if somebody tells me this is too hard, I'm like, well, I mean, I guess you can administer Windows or administer, like, I can't make the Linux side of it any easier, right? Or the security side of it any easier. But everybody wants to do security. Everybody thinks they want to do security until they see the work and they see those STIGs and they're like, wait, I got to do this all the time. And it's like, yeah, this is what we do. Like, this is how we report out to government and businesses and people that have these security standards that are not just slap a server down for me. Most people don't just let you slap a server down for them. You have to harden the box and make it. And then what am I just going to prove? Am I just going to trust somebody that they hardened it, or am I going to have it hardened to a standard that they can prove and they can show me the auditable things that happened as they built that system? That's what that tool does. It helps us to gather that all out. So anyways, why is it important to verify that the package is not in your system? Oh, well, before I go back to that, Monkey Man, hopefully that answered your question. The security engineering course is done. I don't really have a plan to run the new one. The next course I plan on running is going to be like a 16-week automation course using Ansible and Python, probably some Bash too, just for fun. That's my goal. That's my plan. Now, that being said, for people that are interested in doing the course but not getting some kind of thing out of it, like not getting a cert, the cool little cert that we had made, you could just go and do the course. It's all free right here. You can, you know, this is up in the Discord, but I've also linked this multiple times today. You could go do the course for free, right? You can go spend your time and work through it and think it and take notes and stuff. It's just you're not going to get our cool little certificate. That's only for people that actually run through the actual course with us. And I actually have to go check, but it's like some people didn't finish the discussion post for the security engineering, and it's like that's a hard line that I draw for finishing. Like, if you're not going to do, and I can see missing 1 or 2 because people make mistakes, but like if you didn't do any of them, like, as far as I'm concerned, you're not in the course, right? Which, I mean, you turn everything else in nice, but if you didn't do the discussions, I don't consider you part of the course. And like, that's probably going to hurt some people's feelings, but it's irrelevant. Like, the way we learn things, it's good to bounce ideas off of other people. It's not just good to hear me talk about it. You should hear it in your own head as you think through and learn it, and then also talk to other people and stuff. So that's a big part of it for me. Anyways, I'm not, we're not even worried about the course. I was just playing that video a little while ago for you guys. But let's go back into this. Let's keep working on this. This is the focus of today. So why is it so important to verify that the package is not in your system? Well, because we're changing, we may be the software bill of materials, SBOM, right? So I'm saying from the first one. And then question, I still cannot, I cannot still commit. It says it's actually hard to figure out and say connect to these logical stuff. I gave up, sorry. Yeah, Fractal, I can't, I can only, I can show people all these things, but I need people to get in there and work on stuff, right? And I can't, I'm not going to set anybody else's priority. I think people should probably spend, at least 15 to 20 minutes a day on this stuff if they want to learn it. But then you probably have to spend some time over the weekend too. But yeah, I can't make this a priority for anybody else. Like, you guys have to do that yourself. So there's that. Monkey Man said, yes, of course, asked because I saw a scheduled session for the sysadmin course. Yeah, the sysadmin course is still going. That one is, they're in week 12, so next week is week 13, and then, but next week I'm not going to be around, so we're probably going to skip 13, and then we got 13, 14, 15, 16. One of those is going to fall when I'm in Mexico in July, so I'll be down in Mexico, and then, yeah, I guess we'll kind of go from there. So, okay, so we see this installed, and we can look and we can see the packages. We can see that it's opened up ports, and we can see that it's running the Apache server, right? So here's the Apache server running, and we can see the slices, and we can see what process is running it. And then this is maybe important right here to know, why is it important to know what port it is listening on? Well, that lets us know are being or are exposed in the system and need. So if you're going to open up a bunch of ports on your systems, know that security or the team that maintains those kind of things needs to know what's happening with that. Why is it exposed? If they come and do a scan and you don't have a reason that port 80 is open, well, now you got to answer questions for, you got to answer questions about that. So then what is the user that is, so what is the user that is running the HTTPD process or the, yeah. And we might find that by doing something like ps-ef grep-i apache 2, and we see this www-data. That's interesting. Up here we saw when we did an LSOF for the PID, excuse me, we saw this Apache 2 as the command, and then yeah, there's the user www-data. So right, or what did I look for? Apache 2, right? Yeah. And why is it important to know that? Well, because I might want to know the behavior of that user. What can that user do? So clear the screen, grep www from etc pass wd. There's 7 fields across here, and okay, this is kind of good. He's got a user sbin no login set as his shell. So if somebody were to ask me, can that www-data user get in as a terminal shell, can he have a VTY or any type of shell on my system? The answer is no. He can't set up a terminal because he can't get to a shell. So that's one way in which we protect the Linux box from user processes who could be compromised. Let's say somebody gets in and compromises our system because there's some well-known metasploit against 2.4. Whatever our version was, right? We had this specific version here. And against 2.4.58, some vulnerability comes out and we get compromised from the external side of things. And then we at least know that if they take over that user, they're not going to be able to spawn an interactive shell. That's not to say they can't be destructive. They can probably still do some other things, which we can look at. That's where contexts come in and are useful with SE Linux and stuff. But no, right here, we should be able to look at this and go, okay, we've got this version of the system, so maybe we got to protect it a little more because we know it's got vulnerabilities. We're tracking vulnerabilities for our software packages and tracking what's popping up with, that the script kiddies are going to just run as a scan against our environment. And then we think about how to protect these things, right? All right, anyway, so firewall status inactive. We can exit back out, and we should be able to curl that node on port 80. Port 80 is also the default, so we could have just curled the node. And we see the basic page come up that we are able to connect into that system. That's good. That means that that's a long page. Jeez, there's our web page for that node. All of that. So we got in. We're good. And then did we see our default web page? Yes. All right. So now we set up our web server. We're going to set up 3 different listeners and 3 different document routes for our web server. So our web server is operating on port 80. We're going to set up a dev, a test, and a QA environment inside of the web server using a thing called directives to open port 80 with a listener, port 81 with a listener, and port 82. And then they're going to go into the right document routes and read and present only the web pages that they're supposed to. So we're going to do this very, very simple thing. But if nobody's ever showed it to you, it's not super simple, right? You're like, oh, Scott's calling this simple, but I don't know what it is. Well, once you understand it and get it working, it's going to be super, super simple for you. So let's go in here. Let's go look at it. And we're going to go back to node 01. And we're going to make directories for 3 directories. So if we cd to var www, do an ls-l in here, we only see this one HTML directory, right? And we're going to make these other ones. So if we do an ls-l in there now, we see these other ones, right? So now, we might say, what are the permissions of the directories we intend to use as document root? And the answer to that is ls-l on var www, really everything, but HTML everything, right? And that'll show us that the permissions are their directories 755 in HTML, HTML_dev, QA, and test. Now, we're setting this up by hand, but in one of the labs for Ansible, I show you guys how to do this with Ansible, so it just does everything itself, right? But this is how we're going to get started. Now, the next thing we're going to do is we're going to go look in our Etsy Apache 2 ports. So if we were to cd to Etsy Apache 2, Apache 2. In here, there's a bunch of stuff, but we're going to go look at ports. So vi ports.conf. And in here, we're listening on port 80 only. That's the only thing that we're listening to. But we can say YYP and set this to 8080. Whoops. YYPP. And then hit like R1 and R2. Or we could have copied it out of over here. But now we're going to listen on these other ports. Okay, that's fine. But if we don't tell our system how to behave and treat those listeners, we don't know where to go read from with those listeners. Those are just kind of dangling. So let's go look at where that's defined. So we right quit that. Again, it's nothing's being exposed on our system. We haven't done a restart yet. But now we're going to go look in this cd2 in here. Sites-enabled. I could type. And the one that's there already is this big, long virtual host. Let's move this over here a little bit. For 80. And there's some things right here. There's a server admin and a document root and then some error stuff. Well, we're going to go take... All these comments don't matter. These comments are just noise. We really only care about like 4 of these lines in here inside of the directive. So let's go out of here. And in here, we're going to VI one called testing team.conf. Doesn't really matter what we call it. And we're going to add these 3 directives that hopefully will kind of make sense to you guys when you look at them. So let's look at this first one. Virtual host, and we're going to listen on port 8080. We're also listening. We've defined that over there. The document root is going to be, or the server admin is going to be whoever. The document root is going to be one of those directories we made earlier, var www html_dev. And the logs for it are going to be dev_error.log and dev_access.log. Now, that same thing is going to be true for test right here. So test. And then the same is going to be true for QA, quality assurance, right here. So we made 3 directives. One is for virtual host 8080. The next one is for virtual host 8081. And the last one is for virtual host 8082. That's all we did. 3 directives. They drop in here. I'm going to escape :WQ. And then now is we're going to make a index page in each of those. So I'm going to go look at the HTML_dev, and I'm going to make an index page in here. And it's going to be the simplest HTML I can possibly make that will still work. It's going to look like that right there. It's going to say this is the dev page. Then we're going to go look on the test page. Test page is going to look like this. There's the test page, test environment. And then we're going to go look at the QA page. And the QA page is going to say that it's the QA page. So now when you hit these, when we finally get this running, as you drop into each of those different document roots based on each of those listeners and then the directives, it's going to make us go and do all these things. So we're going to restart Apache 2 on this box. And then now if we go and we listen, we'll see 8080 being listened to, 8081 being listened to, and 8082 being listened to on our system. And then now if we listen real quick, if we just hit this box, we'll see the dev, the test, and the QA against port 8080, 8081, and 8082. So we just set up those little environment type things in our system. So I'm going to move this over here, right? And then we're going to check, and it should be good. And said, look at you learning Linux configurations. You've set up these base components to be able to talk to whatever's going on inside of that device, right? So over here, we might say, what ports did you open on the listeners? And then that was, you need to know to do that. That was going to be in the ports.conf. So that was maybe cat out etc apache to ports.conf, right? And then how did you set the directives to point to the correct document root for each of them? And that looked much more like this. If we go back one here and we look at our solution, each one of those directives look like this, right? And it's pretty straightforward when you look at it. Like it might be a little bit intimidating at first, but we turned on the directive here, virtual host, anything on port 8080, and then we turned it off down here. We had the server admin, which would be some email if you wanted to use that. And then a document root, which is where we're pointing it to. Cool. And then we had an error log and a custom log so that we knew where we were sending things that didn't, bad queries, bad headers, all that kind of stuff, right? We could throw it all right there. So how did you set each of the directives to point at the correct document roots for each of them? You built those little directives and put them in the right location, which was the which one was that? It should have been a VI for, oh, I see it. Yeah, testing-team.conf in that directory. So, all right. So I think from a security standpoint, that's probably most of the things. But what ports did you open and how did you check that? And you checked that with something like lsof let's do it like this, ss-ntulp. You could do that to check, and you can do lsof-I on like 8080 or whatever, and you can see what's holding those open. So those are our different commands here. Now, important things to kind of know here is if we cat, or let's say we grep 8080 from Etsy services, that's going to tell us what that port should have been, which is HTTP alt. And we saw that when we actually looked at our SS. And then we can also see in here some of these other ones. So there's a transparent proxy, which was typically 8081, and 8082 doesn't have any defined names. So why that matters is when you do your bang SS here, you should see in that NTULP for port 80 was mapped to being called, well, actually we forced it to be numeric. If we drop the N off of that, let's pull off the numeric, and then that'll give us the actual numbers now. Oh yeah, you know what? Actually, some of those things won't even show up now. It's funny. We have to do that without them because the numbering won't help us anymore. Now we got to look at everything, and we would see 8082, but now instead of seeing 8081, we see the T proxy, and instead of seeing 8080, we see the HTTP-alt. So we're not getting the numbering anymore. So that's kind of a, I guess, a useful thing to know the behaviors of your SS, like how you're doing your queries, because you're not going to get that 80. You're not going to find anything. So there we kind of go with that. All right. So, but with that, we'll probably call it a day. I wasn't going to be on too long today, but we did a couple of labs. We have a whole bunch of labs here, which, you know, the labs are just doing Linux-y things, right? Just doing a bunch of stuff in Linux. You're building, today we did NFS, and then we did, so we did NFS, and then we also did Apache. But up here, we have all these other ones that we've kind of done. So like attempted user logins and what we need to know around that. And what I've tried to do in these is show you that like there's the things we have to do to get through the lab and to get a check mark. But there's all these other things that we can go read about and study and know to be better at doing this stuff from like a security standpoint. So these are all up in the Discord. I got to add these next two. Probably, maybe I'll throw the whole thing up there. But we've just been kind of adding this as we kind of go through the system. So I'll probably pop on my little end of stream thing here. I definitely appreciate everybody coming by. You guys are always welcome to hang out and talk shop and do Linux-y things with us.